a new topic, that is the determination of transfer function of mechanical system. So just give me a 2 minutes of time. What happened in the previous class, I just recall, as it's a new topic to all of you. The students who understood the things, please bear the things. For just 1 minute, I'm not taking much more time. So here with this slide, I started yesterday's class. And before that, I have shared you what are the topics what we have completed and what are the topics left over in your unit 1. Now we are discussing the second problematic topic, that is the transfer function of mechanical system. What is mechanical system? All the physical objects which are moving in the field of engineering comes under mechanical engineering. Few of the examples I have given, and few of the examples already you are using in your daily life. Examples: lift, cars, bikes, buses, etc. All are comes under mechanical engineering. It's complete study how it is moving, how to design that particular machine or that particular system. Everything comes under mechanical system. And based upon the motion, this mechanical system has been classified into two types. One is mechanical translatory system and the second one is mechanical rotatory system, what we have discussed in the previous class. And coming to mechanical translatory system, single line definition I have given you, that if a body is moving from one place to another place, that comes under mechanical translatory system. Few of the examples in graphical view I have shown so that it will be easy for the students to understand the concept. And the example of rotational system I have considered is a fan. Fan is also a moving physical object, but the place of that particular fan never change. So the physical quantities which are moving, but they are moving around its fixed axis, comes under mechanical rotational systems. That we have given you the graphical two examples of mechanical rotational system, where there is no there is a movement, but the axis is constant. Now coming to the elements, similar to your, if you consider electrical circuits, the elements under electrical circuits are R, L and C, and the variables what we consider in the electrical circuit are voltage and current. It's in the same way here also in case of mechanical systems, there are three elements: mass and the frictional element, in other words dashpot, are also known as damper element, denoted by capital B, and the graphical symbol I have shown here. In the same way, the spring art, what you have already used in your daily life, even though I have taken the example of hair bands of the hair bands what the girls are using, that comes under the spring capital K. These are the technical definitions of these three elements, and all of you are aware that from the knowledge of physics what is force and what is displacement. So here in case of mechanical translatory system, if you to move a particular object, you need to apply some force. Once if you apply the force, the resultant will be the displacement x. In the same way here, coming to mechanical rotational system, same everything, three elements and two variables, but only the symbol has been changed from of mass from M to capital J. Where what is capital J? Capital J represents the motion of rotational body, and what is force has been just replaced by torque in case of rotational motion, and the displacement replaced by theta. Remaining all are same. And next I have given you the basic mathematical relationship between the elements and the variables force and the displacement x, similar to your resistance and voltage source, what you know all of you from the knowledge of your electrical circuit, R, L, C and the variables V and I ki madhya, the relations are I have just kept at the right side. Now here in the same way here also, in case of mass, F is equal to M into d square x by dt square. You consider only one variable. Generally in a generalized way, we will consider only one variable. You can consider the output variables are displacement x. If we are having some displacement, then definitely surely you will be having what, some velocity. In the same way, if you are having velocity, for sure you will be having some acceleration. So you just ignore acceleration and velocity, just consider the displacement as the output variable. We will write the expression only in terms of output variable. As you are writing the expressions in terms of voltage and current, even though you are having, all of you are aware that I is equal to dq by dt, you can write the expression directly in case of charge also, but we are not writing, we are considered one single constant common element, so that it will be easy for you, for everybody to identify the things clearly. Rather than writing the expression in terms of charge, we are writing directly in terms of what current. If current is there, then 100% charge అనేది ఉంటుంది, that is I is equal to dq by dt. In the same way, hence displacement is there means velocity will also be available. But as a part of your curriculum, here we are not considering velocity and acceleration. Remember that point. And for force, for the element capital B, that is ampere element, the mathematical relationship is F is equal to B into dx by dt. And in the same way, for the spring element, if you apply some force on a spring, then you will be getting some resultant displacement x, which is the relationship will be F is equal to k into x. All these formulas are from the laws of basic mechanical motions. We are not deriving anything here, as we are not studying any mechanical engineering. Here, in the same way, in case of mechanical rotational system, the mass is replaced by J, and the T is the replacement of force, and theta is the replacement of displacement x. Remaining all are same. Now next, I have solved two problems in the previous class. So this is the procedure. As a new topic కాబట్టి ఒక 5 minutes repeat చేస్తున్నాము, no further repetition more. And so this is the problem. For the given problem, first ఏం చేయాలా మీరు, how many number of displacements are there problem లో ఇచ్చింటాడు. Based upon that displacement, assume the number of nodes. After that one, you need to draw the free body diagram by identifying for which elements are connected to which node. So based upon that one, you are going to draw the free body diagram. And based upon the number of nodes, you need to write the force balance equation. I can say here, instead of differential equation, I can use the term force balance equation. And then finally, last two steps are similar to your electrical system, then applying Laplace transformation and then rearranging the terms to get the ratio of what output by input. Now let me go for solving the next problems. Problem number 3. So please note down in parallel with me. So here I am going with problem number 3. Third problem. So determine the transfer function. The question is determine the transfer function for the following mechanical system. Please note down in parallel with me. This is the question connected with some spring. So it's a single traction. Trains ఉంటుంది కదా, single bogie train equivalent diagram, mechanical. One bogie M. applied force F. Due to this force in the same direction, x1 is the displacement. Let x2 is the displacement at M. Second displacement he has given K1, K2. Let me rechange this diagram. Let me make you little bit more complex this diagram. Electric traction చెప్పినాను కాబట్టి I am just making this one as this is the ground and these are the wheels with friction B, and let this the displacement here is x2. So I will solve this problem, don't worry. Let this is x1. Now solution here is, so as a first step you need to assume the nodes. Here in this given problem there are two variables are there. One is x1 and another one is x2. So to draw the free body diagram, from this given diagram you have to identify the elements which are connected alone to x1 and then the elements which are connected alone to x2. If you observe here at the x1 side, so here x1 side key one variable is there named as force and another element connected is what, K1. So now here first step for you is you need to identify the elements which are connected to x1 alone, x2 alone and common between x1 and x2. So here as a part of this first step I can write only force is connected to x1. Only force variable is connected to x1. Why means, as if you observe this K1 is connected at x1 and also the another end of K1 is connected to some another terminals, some another elements. Hence you can't consider this K1 as a element which is connected only to what, x1. Just like if you observe K2 one terminal is connected at the side of x2 and other side is connected to ground, no further other connection. Hence I can say K2 is only connected to x1. In the same way here, so for the elements which are connected to alone x2 can be considered as the mass M which is at x by default and the element B and the element K2, and the common element can be considered between x1 and x2 is K1. Here is the first part. Okay, now next part is you need to draw the free body diagram. So to draw the free body diagram here, first step is you have to go for assuming, based upon the given problem you need to assume the number of nodes. Now here if you observe here the elements which are connected to x1 is only what, only the force F. You just draw. What is free body diagram? Yesterday I told you, based upon the node connections draw in parallel with everything. So x1 ki force undi, danto parallel rastam. Next x2 kilo emunnemo, one element is M. Next two elements are, one is B. The symbol of B is like this graphical symbol. And another element is K. So this is B and this is K. Now the common element between x1 and x2 is K. K1 is the common. This is the free body diagram, second step. Free body diagram. And these are the first identification. Now next ఇక్కడ ఇంకోటి విషయం ఏమంటే ఇక్కడ చాలా మందికి డౌట్ రావచ్చు, ఏమి x1 అనేది x2 అనే మధ్యలో ఫిజికల్లీ చూస్తే హౌ మెనీ ఎలిమెంట్స్ ఆర్ దేర్, M and K1 ఉంది. చాలా మందికి ఈ డౌట్స్ కంపల్సరీ రావాలా ఒకవేళ ఇఫ్ యు ఆర్ లిజనింగ్ కేర్ఫుల్లీ. ఇక్కడ అబ్జర్వ్ చేస్తే హియర్ ద ఎలిమెంట్ బి ఈజ్ అనదర్ ఎండ్ ఈస్ కనెక్టెడ్ టు గ్రౌండ్, హెన్స్ డైరెక్ట్లీ యూ కెన్ కన్సిడర్ ఇట్ ఈస్ కనెక్టెడ్ అట్ x2 and k2 another end is connected to ground, you can consider. But if you observe m and k1, both are in between x1 and x2 physically. Of course, if even though if they are in between physically k1 and m, but if you observe mass is the mass purely mass element and k1 is the spring. So ikkada mass ki spring ki madhya differentiation manam chuste, spring will be having what, if you observe this mass element, మీరు ఇది ఇట్లా కనెక్ట్ చేసి స్ప్రింగ్ కి, if you pull this one and release, then the movement will be for the spring will be up and down movement ఉంటుంది, టూ సైడ్ డైరెక్షన్స్ లో ఉంటుంది. అదే మాస్ ఉంటే if you apply the force from here only one direction లో ఉంటుంది, సో డిస్ప్లేస్మెంట్ విల్ బి ఓన్లీ ఏదో ఒక డైరెక్షన్ లో ఉంటుంది, ఈవెన్ దో ఇఫ్ ఇట్ ఈస్ కనెక్టెడ్ అట్ బోత్ ద ఎండ్స్. నేను సింపుల్ గా ఎగ్జాంపుల్ తీసుకుంటాను. నా దగ్గర ఒక ఆబ్జెక్ట్ ఉంది ఈ పాయింట్ x1 దగ్గర, ఓకే, ఒక పాయింట్ దగ్గర. సో నేను సమ్ ఫోర్స్ అప్లై చేస్తున్నాను. వాట్ ఈస్ ద ఫోర్స్? సమ్ ఇఫ్ ఐ యామ్ గోయింగ్ టు అప్లై సమ్ ఫోర్స్ టు దిస్ పర్టికులర్ ఎలిమెంట్ మాస్, డ్యూ టు దిస్ ఫోర్స్ let me from this point to here it has traveled up to here. So present initial position is here. Due to this force let that this distance is up to here. ఇక్కడ నుంచి ఇక్కడికి distance is x1. తర్వాత one more force is opposing from here to this particular same mass element. ఇది ఇక్కడికి వచ్చిన తర్వాత one same డైరెక్షన్ లో ఇంకో ఆపోజిట్ డైరెక్షన్ లో ఫోర్స్ అప్లై చేస్తే లెట్ ఇంతవరకు వచ్చి ఆగిపోయింది అనుకో, మాస్ 2. దిస్ డిస్ప్లేస్మెంట్ ఈజ్ వాట్, లెట్ x2. వాట్ విల్ బి ద టోటల్ డిస్ప్లేస్మెంట్ ఆఫ్ మాస్? ఫస్ట్ ఇనిషియల్ పొజిషన్ ఈజ్ దిస్ వన్, తర్వాత ఇది ఫైనల్ పొజిషన్ ఈజ్ దిస్ వన్. సో ఫస్ట్ ఫోర్స్ అప్లై చేస్తే ఇంత దూరం పోయింది, మళ్ళీ ఇక్కడ నుంచి ఆపోజిట్ డైరెక్షన్ లో ఫోర్స్ వల్ల ఇక్కడ ఉంది. టోటల్ డిస్ప్లేస్మెంట్ ఏమొచ్చింది? x1 minus x2. So this is going to happen in case of springs. ఎందుకంటే స్ప్రింగ్ లో టు అండ్ ఫ్రో మూవ్మెంట్ ఉంటుంది. నేను ఒకసారి ఫోర్స్ అప్లై చేస్తే ఇది పైకి వెళ్ళి మళ్ళీ కిందికి వస్తుంది. రిజల్టెంట్ డిస్ప్లేస్మెంట్ విల్ బి వాట్, డిఫరెన్స్ ఆఫ్ దిస్ x1 minus x2. బట్ ఇఫ్ యూ అబ్జర్వ్ దిస్ మాస్ ఎలిమెంట్ కి మీరు ఫోర్స్ అప్లై చేస్తే ఇట్ ఒకటే డైరెక్షన్ లో మూవ్ అవుతుంది, అంటే x1 ఉంటుంది, మళ్ళీ బ్యాక్ సైడ్ వచ్చేది ఛాన్స్ లేదు మాస్ ఎలిమెంట్ కి. బట్ ఫర్ స్ప్రింగ్ ఎలిమెంట్స్ అండ్ దిస్ గ్రీజీ ఎలిమెంట్స్ డాష్ పార్ట్ ఇలా ఉంటుందమ్మా, డాష్ పార్ట్ అప్ అండ్ డౌన్ మూవ్మెంట్ ఉంటుంది, పిస్టన్ రాడ్ ఇది. సో ఈ టూ ఫర్ బి అండ్ కే ఇన్ జనరల్ యూ విల్ బి హ్యావింగ్ వాట్, ద డిస్ప్లేస్మెంట్ అట్ బోత్ ద సైడ్స్. బట్ ఫర్ మాస్ ఎలిమెంట్ ద డిస్ప్లేస్మెంట్ 100% will not be at both the sides. Hence, while considering this extraction of common elements, you should not అంటే ఇంటూ మార్క్ చెప్తున్నాను, స్టార్ పెట్టి ఇంటూ మార్క్ ఈజ్ you should not go for considering mass element as common element. ఎందుకు అంటే ఇందాక ఎక్స్ప్లెయిన్ చేసినాను. అదే స్ప్రింగ్ ఉంది అంటే ఒక ఫోర్స్ అప్లై చేస్తే ముందుకు పోయి మళ్ళీ వెనక్కి వస్తుంది, లెట్ మీ స్ప్రింగ్ వల్ల ఇదే జరిగేది. సో హెన్స్ టోటల్ డిస్ప్లేస్మెంట్ విల్ బి x1 minus x2. ఇక్కడికి వచ్చి ఉంటుంది ఫైనల్ డెస్టినేషన్. కానీ అదే మాస్ అనుకుంటే ఫోర్స్ అప్లై చేస్తే ముందుకే వెళ్ళిపోతుంటుంది. మీన్స్ డిస్ప్లేస్మెంట్ విల్ బి 1 ఈవెన్ దో ఇట్ ఈస్ కనెక్టెడ్ టు బోత్. ఏది ఫోర్స్ ఎక్కువ, ఇప్పుడు సపోజ్ వస్తువు ఉంది, ఒక వస్తువుకి ఆపోజిట్ డైరెక్షన్ లో ఒకరు, ఇంకో డైరెక్షన్ లో ఒకరు, ఇఫ్ యు ఆర్ అప్లైయింగ్ సమ్ ఫోర్స్, సో ఎవరిది ఫోర్స్ ఎక్కువ ఉందంటే దట్ విల్ ఓవర్కమ్ and that will move in that particular direction, purely mass element. Okay, so in the same way here also important note, what you need to note that for mass you should not consider the common element, but B and K both are having to and fro movement kabatti you have to consider that one as a common elements. You can consider okavela possibility undi ante. So ikkada nenu ee explanation enduku ichina ante x1 ki x2 ki madhya two elements are there, one is mass, another one is K, but among those two, K and mass only will be considered at x2, while as K1 can be considered a common element between x1 and also the x2. Now the third step is writing the differential equation here. So first equation em rayala, enni nodes unte anni equations vastayam. First equation is at node x1. So what you can write the equation for node x1. So at node x1, the equation you can write the force F is equal to any element connected to this particular one. Here applied force is this one. How many elements are connected? Only one element. So which is known as what? K1 into. So here K1 is connected to x2 kavati. As you are writing with respect to x1, you will get K1 into x1 minus x2 is the equation 1. And now what about second equation? That is at node 2, at node x2, at node x2. What is the applied force? Is at this particular node there are no forces, so hence left hand side is 0. Coming to the force balance equation, applying ikkada apply cheyalam, apply force balance equation. Here also the same. Okay, 0 is equal to, what is the relationship between force and displacement x2? M into d square x2 by dt square plus b into, with respect to, when it is b, it is only dx2 by dt plus k into x2, equation 2. Antena? Maybe plus, sorry, k, this is not k, k1. k1 into x2 అంతవరకు అయిపోయింది. దాంతో పాటు ఇంకో ఎలిమెంట్ కూడా ఉంది. సారీ, దిస్ ఈజ్ k2 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 into x2 ప్లస్ దాంతో పాటు ఇంకో ఎలిమెంట్ ఏముందమ్మా, ప్లస్ k1 is connected between common, hence now this time x2 minus x1, equation 2. ఇది కరెక్ట్ రాసేస్తే ఆల్మోస్ట్ ఎండ్ ఆఫ్ ద ప్రాబ్లం. Now in this problem he has asked you to find x1 of s by f of s. Find the transfer function in terms of x1 of s by f of s. Now applying Laplace transformation, you will be getting f of s is equal to k1 into x1 of s minus k1 into x2 of s, equation 3. Next is, if you observe this equation, from this equation there are variables obtained. The aim of this problem is you need to get x1 by f. So here left hand side f is there, right hand side x1 is there, which is required, but I don't want this x2 of s. So x2 of s నాకు అవసరం లేదు. So hence this x2 in this problem can be considered as an unknown variable. So how to eliminate this unknown variable? By using the application of second equation, writing the x2 in terms of x1, you will get the final answer. So how you applying Laplace for the second equation, then 0 is equal to, directly rastunana, m into s square plus b into s, Laplace of differentiation s square and s, plus k2 plus k1 కామన్ తీసుకుంటాను డైరెక్ట్ గా ఫైనల్ గా x2 of s minus k1 into x1 of s, or further I can write x1 of s is equal to, idi if you send this negative term to the right side, you will get here what, m s square plus bs plus k2 plus k1 divided by k1 into x2 of s. Now if you have actually, I'm sorry, I need what, x2 of s. Hence ఎందుకంటే క్వశ్చన్ లో x1 అడిగినాడు కాబట్టి, so to get the x2 of s I need actually x2 of s. So x2 of s will be equal to opposite. So x2 of s will be equal to, if you send this towards left side, then x2 of s will be equal to k1 divided by m s square plus ps plus k2 plus k1 into x1 of s, equation 4. Now final answer you are going to get by substituting. So next step is substitute 4 in substitute 4 in 3. If you substitute 4 and 3, then here x2 place lo x1 ne vastadi. Then rearrange the terms, you will get the final answer. Now I am just removing this free body diagram as I have already written the equations to get my final answer. So what you will get if you substitute, let me take another color so that students confusion comes. So what you will get here, if you substitute that equation, then f of s is equal to as usual k1 into x1 of s minus, in case of x2 of s, you have to write what k1 already undi into k1 divided by m s square plus bs plus k2 plus k1 into x1 of s into x1 of s. Next, if you just cross multiply these things with respect to this one, then in numerator changes to which is equal to numerator changes to, if you cross multiply this one to the top side, you will get m k1 s square plus b k1 s plus k1 k2 plus k1 square minus k1 square divided by m s square plus bs plus k2 plus k1. Now these two will be into x1 of s. Now final answer will be x1 of s divided by f of s is equal to, now sending these parameters to the right side, numerator and denominator are going to change. Numerator and denominator are going to change. That's it. So your final answer is, in the numerator you will get m into s square plus bs plus k1 plus k2 divided by m k1 s square plus b k1 s plus k1 into k2 is the final answer. Any doubts? Unmute, you can talk. That is the transfer function for the given question. Here is the end of my first problem. Take the screenshot. You can verify it later on. Any doubts? Unmute and talk. Don't hesitate here. So if it is over, then I am going for next problem. So the conclusion of this problem is, first step is you have to identify the node elements. That is the most important. You need to identify the node elements. How many nodes he has given, you have to identify. So next, problem number 4. Problem number 4. So I got one question. What happened when K1 and K2 in common means you need to consider the common elements as usual. Let me go with the next problem to solve further, to move on further. Don't worry, two more classes will be taken to complete this mechanical system. At the end of the fourth class, you will come to understood exactly here. The fourth problem here, just I am going with this considering this problem. Now this problem you please try to solve with me in parallel with more speed. So here I am having M1 B2 M2 K B1 M1. Let I am applying the force in the top from bottom F. Due to this force, let x1 is the displacement from here, and let at mass m2 the displacement. Not let he has given in the problem. This is the question for you. Inga confusion either. Let me clear this one. I will write like this: x2, and this is x1. So x2 is the displacement at the mass m2, m1 దగ్గర displacement. ఈ problem మీరు clear గా చేస్తే you will. Now here I am asking here determine the ratio of x2 of s by f of s. So here in this problem you need to find out x2 of s by f of s. To solve this one as a part of your solution here, first step is here you need to identify x1 alone elements, x2 alone elements, and the common between x1 and x2. Once if you have done clearly about this particular data, then problem is over. Tarvata em leduma, simple mathematics. So now if you observe here in this particular problem, the variables which are connected to at this particular junction x1, one is force, another one is m1, another one is b1, and another one is b2. Now from this one, by default, force will be force as a variable can be considered as connected to at x1. Next, the element mass, as I told you, mass always unte, either it will be for x1 or x2 or x3, whatever it may be, he has given. So mass m1, and now if you observe this one, chala mandi ikkada one, you may get the doubt that as here the variable serial number is x1, so hence b1 is related to x1 and b2 is related to x2. Now if you observe here, x2 is at this particular junction. Here there is no physical connection between b2 and x2. Of course the serial number is same, x2 and b2 serial number is same, but you should not identify. You need to extract this data, the step number 1 data, in such a way that from the physical, so the data in the first step can be extracted from the physical view, physical connection. Remember that one. So here if we observe this b2, one end is connected at mass m1, which is at the junction of x1, and another end is connected to ground, no further connection. Hence you can consider this b2 element are related to x1. And for x2, if you observe, I told you already in the previous problem that by default one element is there, which is k. One end is connected at x2 and another one is grounded. Hence general ga k anedi చూస్తేనే చెప్పేయచ్చు it is alone connected to x2. Now ఇక్కడ ambiguity, you will be getting an ambiguity between b2 and m2 and b1. In terms of physical appearance, this m2 and b1 are connected between x1 and x2, but among these two you need to consider only b1 as a common element between x1 and x2. You should not consider this m2 mass element as a, so ఇక్కడ m2 if you are not considering as a common element, by default అది ఉంటే x1 కి ఉంటుంది లేదంటే x2 ఏది నియర్ బై ఉంటే you need to consider that one. Obviously it is connected with x2 కాబట్టి here m2 can be considered as this one. So like this you need to consider. గుర్తుపెట్టుకోనమ్మా, previous problem లో the common element you got as k. Now in this problem the common element you got as b1. ఇచ్చిన డయాగ్రామ్ ని బట్టి ఇచ్చిన ప్రీవియస్ ప్రాబ్లమ్ లో k అండ్ m కామన్ గా కనిపించినాయి ఫిజికల్ గా, అందులో I have ignored m and I have considered what k. In the same way here in this problem m and b1 has been in terms of appearance, physical appearance common between x2 and x1, but m2 అనేది ఇగ్నోర్. ఎందుకు ఇగ్నోర్ చేయాలంటే ఇంతకుముందే ఎగ్జాంపుల్ చెప్తున్నాను, m2 కంప్లీట్ వెయిట్ ఉన్న వస్తువులు ఏమైనా ఉండని మెకానికల్ సిస్టమ్స్ లో ఇట్ విల్ ట్రావెల్ ఇన్ సింగిల్ డైరెక్షన్, అది గుర్తుపెట్టుకోండి. దట్స్ వై సింగిల్ డైరెక్షన్ లో ఉంది కాబట్టి యూ కాంట్ కన్సిడర్ ద డిఫరెన్స్ ఆఫ్ డిస్ప్లేస్మెంట్ లైక్ దిస్. కే అనేది బోత్ డైరెక్షన్ కాబట్టి టూ డిస్ప్లేస్మెంట్స్ ఉంటాయి. స్ప్రింగ్ మీరు లాగితే అప్ అండ్ డౌన్ మూవ్ అవుతుంది. సో హెన్స్ అలాంటి డివైసెస్ కి వీ కెన్ కన్సిడర్ యాజ్ ఎ లైక్ దిస్. మనం ఎలక్ట్రికల్ సర్క్యూట్స్ లో మనం కన్సిడర్ చేసినాం. యూ హ్యావ్ కన్సిడర్ in case of it's just like an electrical circuit consists of elements in common with two loops like this. So if in the current flowing here, compulsory the current flowing through here is water, the difference of water I1 and I2. Here also in the same way, if the element is connected either B or K, gurtupetukonama, there are three elements. From these three elements you must consider the B and K can be considered as a movement having to and fro movement means they can travel in both they can, once if you apply some force there may be a chances of having getting the displacement in both the direction. Example is spring. మీరు స్ప్రింగ్ చూస్తున్నారు కాబట్టి నెంబర్ ఆఫ్ టైమ్స్ ఐఎమ్ టేకింగ్ ద ఎగ్జాంపుల్ యాజ్ స్ప్రింగ్. డాష్ పార్ట్ చాలా మంది చూసిండొచ్చు, చూడకపోయి ఉండొచ్చు, కానీ డాష్ పార్ట్ అనేది ఇలా ఉంటుంది, ఇలా ఒక పిస్టన్ రాడ్ లాగా ఉంటుంది ఇలా. సో ఇట్ విల్ మూవ్ టువర్డ్స్ up to and fro just like మన vehicles లో ఉంటుంది piston rod, అది మ్యాటర్. సో now in this problem first step is, once if you identify correctly then go to draw the free body diagram. So to draw the free body diagram, first step is you need to assume the number of nodes. So how many elements are there here? There are different elements, among which how many nodes are there? There are two nodes. So you need to consider those two nodes as the displacement. So that is your second step. So your second step is, so first how many displacements? One is x1 and another one is x2. Now if you draw the free body diagram for x1, one element is force and next element is mass m. Okay, next element is b. Next element is b2. Next for second element, the one element is m2 at node 2. And how to draw the free body diagram chapter number of times. Once extraction, any elements unde anni parallel ga raseyadame anthem. One element is k. That is your free body diagram. Now next is, ఇవన్నీ ఏ టెక్స్ట్ బుక్స్ లో ఉండవు, మనం అర్థం కావడానికి నేను ఫర్దర్ ఐ యాడెడ్ దీస్ స్టెప్స్. వన్స్ యూ ఫెమిలియర్, నో నీడ్ ఆఫ్ హ్యావింగ్ ఫ్రీ బాడీ డయాగ్రామ్. ఇది చూస్తేనే డైరెక్ట్లీ యూ కెన్ రైట్ ద ఈక్వేషన్స్. సో ద కామన్ ఎలిమెంట్ ఇస్ the B. The common element is B1. In this case B1. This is M1. Force M2. Now writing the equations. So first writing there are two nodes. Hence writing the separate equations for each and everything. So first at node 1, at node x1, what you will get the equation for here? Input is force F is equal to, so m1 into d square m1 is d square x1 by dt square plus b2 into d x1 by dt plus b1 into, now for this case as you are writing with respect to dx, x1 dx1 by d2 minus dx2 by dt. Now at node x2, 0, as there is no force, 0 is equal to m2 d square x2 by dt square plus one more element is there, that is k into x2 plus b1 into, now this time it is what, dx2 by dt minus dx1 by dt. Okay, so here is the almost end of problem. Now next steps is he has asked you to find out what the x2 of s by f of s. So anyhow, for these two equations you have to apply Laplace transformation and then rearrange the terms, you will get the final answer. Rearrange again, you will get the final answer. Now next step is apply Laplace transformation. Applying Laplace transformation. Directly I am writing f of s is equal to m1 s square plus b2 s plus b1 s into x1 of s minus b1 into s into x2 of s. This is equation 3. And then 0 is equal to m2 s square plus k plus b1 s into x2 of s minus b1 into s into x1 of s. Now here x2 వస్తుంది, ఇక్కడ x2 వస్తుంది, x1 వస్తుంది, opposite 4. Now just rearranging this one, as I need what, x2 by f కాబట్టి, now in this problem you have to eliminate this x1 కి eliminate చేయాలంటే just I am sending this towards the left hand side, then you can write the equation for x1 of s is equal to m2 s square plus b1 s plus k divided by b1 into s into x2 of s, equation 5. So now finally substitute equation 5 in equation 3, 5 in 3, then you will get the final answer. I am writing here. Now I am writing the answer as x. Please do this problem. x2 of s by f of s is equal to what you are going to get. I am just writing the answer, please verify. For this case, in the numerator you will be getting alone b1, and in the denominator m1 m2 s power 3 plus m1 b1 m2 b2 m2 b2 plus m2 b1 into s square plus m1 k plus b1 b2 into s plus b1 plus b2 is the answer. And remember, all of you, this is the answer for fourth problem, and this is the answer for third problem. And remember, all of you, generally in general, nobody will see the final answer. Maybe in while cross multiplying, you may miss one single term, but majorly we will be observing the procedure. The procedure means whether you have done this one correct, and right, whether you have written the equations correct or not. That they will see. Once if you are familiar with this one, first two steps no need, directly చూస్తేనే రాయొచ్చు. x1 కి ఏమున్నాయి, directly force equation in terms of Laplace, directly you can write. Within 2 steps you can close this diagram problem. So if you're having any doubts, be feel free here to ask. Let me take the attendance. If you're having doubts, any doubts, please be feel free here to ask. Unmute and you can talk. You can unmute and talk. Okay, here is the end of my first initial classes. In the next week, we will solve few more problems on this one, and then we will be concluding the same thing. We will solve few more problems on mechanical rotational system, and we will be concluding in the next two classes this second problematic topic named as transfer function of mechanical system. So overall conclusion is of today's initial my two classes is I have just started my presentation with this one presentation with the definitions of mechanical system. Okay, so and then I jump to explaining the procedure how to solve the problem, and next the logic behind the solving the problem is whatever it may be the given circuit here, whatever it may be, first మీరు extract చేయాల్సింది ఏమి how many displacements he has given. So based upon displacements number of nodes వస్తాయి. And exam point of view, as we are not testing your mathematics, maximum number of displacement will be getting only 2. ఎందుకంటే 3 displacements వస్తాయి, అప్పుడు 6 equations వస్తాయి. 6 into 6 మళ్ళీ 12 equations కి పోయే ఛాన్సెస్ ఉన్నాయి. Hence we will maximum one from the data of previous question papers, only 2 nodes you will be you are going to get in the exam point of view. So ఇచ్చిన nodes కి ఏవి alone elements, ఏది common elements extract చేస్తే maximum you will be the end of problem. ఇలా extract చేయండి. Next draw the free body diagram. At each node write the force balance equation, then apply Laplace transformation and rearrange the terms in terms of asked variables. In this problem he has asked x2 by f, దానికి equations రాస్తున్నాను. Here is the end of my class. Thank you very much. Now you can log out. Next week we will continue. Thank you.